vectors are our breathing. Vectors are found everywhere, regardless of place and time, on the lands and even beneath them. Vectors are very important and fundamental quantities from which we can express different statistic measurements and crucial concepts in physics. So today, we are going to present you and brief you about these special quantities with magnificent minds. We aspire to inspire you. We bring to put our efforts all together in order to become the true vectors of academic advancement and also educational prosperity. We far and wide, true confidence and genuine spirits. We are the Epitoms. Welcome and good morning for all of you crowds, for all of our respected teachers and guests too. This is Epitoms Group, this 10E. Today this is our first quarter physics journal breakout. We are going to present about the first and the second units of our physics textbook respectively, which were about concepts related to physical vectors or vector quantities and motions as well as uniformly accelerated motions. So today we are going to present different topics. We will have an introductory section. Also we will brief about what vectors are, their types, how to add them, about position and displacement, about average velocity and speed, also about instantaneous speed, about acceleration, free fall, their examples, and how to represent them diagrammatically or using graphs. So we request to attentively follow our presentation. So first our presenter, Hallelujah, will present about positions, about displacement, and instantaneous velocity. So please welcome her to the stage.
One of the most important functions of physics is to describe how things move. But in order to do that, we should know where the things are. Hello everyone, my name is Halil Yamlat, and I'm going to explain some related ideas with motion. In the first main topic, I'm going to explain what position, displacement, and distance are. And under the second main topic, I'm going to explain about average velocity and instantaneous velocity. So let's get started. Saying my computer is found 4 meters to the left is not helpful if you don't know where I am and what do I mean by to the left side. So in order to clear that, we should point out our origin. So in order to clear that, we should point out our reference frame, and a reference frame contains two things. The first thing is origin, or what we call the reference point, and the second thing is ordinate axis. So assume this is my origin. So relative to this origin, I can say to the left and to the right. Now I've got the first axis of my Cartesian coordinate graph, which is the x-axis. And also I have two directions that are upward and downward. And I have got the second axis, which is the y-axis. So let's bring the form example here. My computer is found 4 meters to the left. So assume this is 4 meters. This is 4 meters away from the origin, and the side is to the left side. So exactly, my computer is found here. So now you can realize that I'm telling you two things. The first one is its magnitude, and the second one is its direction. That is, the first thing is that my computer is found 4 meters away from the origin, and the second is it's found in the left direction. So position is completely described by its direction and magnitude. And the other thing is that when we describe a position, we use the units meter, centimeter, kilometer, and other units of length. Let's move on displacement. So we all are familiar with displacement. Displacement is the shortest path followed by an object, but it deals with the overall change in position. So when we are dealing with displacement, it doesn't matter how the particle moves from one position to another position. It only concerns with the initial position, the final position, and the relative position between the two of them. So focus only on the x-axis. This is my initial position. And I mean, this is my origin, and this is my initial position, and this is my final position. So as I said before, displacement is changing position. So displacement is calculated as so our displacement is 2 units to the east, 8 units to the east. So this is all about displacement. Let's move on distance. So distance is the total length measured during a journey or the total path followed by an object. And when we use the word distance, there are two slightly different ways to use the word distance. The first one is to indicate the straight line between 2 points. That means we have position A and position B. If there is a straight line between them, we use the word distance, and also we use the word distance to indicate how far a particle moves. This is also a distance. Distance is a scalar physical quantity. That means it is completely described by its magnitude only. And be careful to distinguish displacement with distance. That means assume a particle that moves in a circular motion. So it starts its movement from here, and it's ended up here. So its distance can be 3 meters, but its displacement is 0, because the initial position is here and the final position is also here. So this is all about distance. So let's move on to the second main topic. The second main topic is about average velocity and instantaneous velocity. So when we say average velocity, it is the total displacement divided by the total time taken, or the total change in displacement divided by the time intervals in which this change occurred. So it could be also defined as a velocity at which a complete journey assumed to be completed. So to calculate average velocity, we use the formula. So this is the formula to calculate average velocity. So the need of calculating average velocity is, as we all know, almost all motions in the earth are irregular. That means they are neither uniform motion nor uniformly accelerated motion. So we need to calculate the average velocity of that motion to get more specific information about that motion. And the last main topic is about instantaneous velocity. So when we start from the word instant, it means at a given specific point of time. So when we say instantaneous velocity, it is the velocity of an object within a given point of time. And the need of calculating instantaneous velocity is to get more accurate value or exact value of velocity on that motion. And the formula to calculate instantaneous velocity is a common formula that we use to calculate instantaneous velocity, that is displacement over time, but the only exception is that the time must approach to 0. So by using instantaneous velocity instead of average velocity, one can get more accurate value of that motion. Thank you for listening. If you have any questions.